This is going on page 49 when we're done. This is going to look very similar to what we did the other day, but it is not exactly the same because day before yesterday we looked at parallel, perpendicular, or neither. Okay, today we're going to look at parallel, intersecting, or coinciding lines. So, do perpendicular lines intersect? Yes, they intersect to form what? 90-degree angles. Yeah, I got to listen to the question that's being asked. Well, just listen to the question. Shh. Perpendicular lines intersect, right? But they intersect at 90-degree angles. Intersecting lines, that includes perpendicular lines, but also any other line that intersects. They don't have to be perpendicular. And when you're talking two-dimensionally in a plane, you only have two options if you have two lines. Either they're parallel or they're not, and they intersect. Okay, so today we're going to look at whether or not they intersect, but we don't really care what the angle is, right? So we've got parallel, intersecting, coinciding. That's where if you graph one line and you graph another one, it graphs right on top of itself. That actually means it's the same line. It's just named differently, or either the equation looks a little bit different. So we know from last year and from a couple days ago that for parallel lines, they have the same slope, different y-intercepts, right? We only looked at slope the other day, and somebody did ask me during the day, well, how do we know they don't have the same y-intercepts? That's a very good question, because we weren't ready to look at that stuff yet. And so we were assuming that when we shouldn't have been, but those problems were given to you in such a way where they couldn't have been coinciding, so all we were really looking at was the slope, even though they also have different y-intercepts. So intersecting. Well, if they're perpendicular, we know that the slopes are what? Negative reciprocals, thank you. But if they're intersecting, that just means that they're different. They could be negative reciprocals, but they're just not the same, and that's all that matters. That means they intersect at some angle. We don't know what it is. We don't even care. Okay. Then we have coinciding lines. That's when you have the same slope and the same y-intercept. So it's one line. It's the same line. It's just one line on top of another one. Just like you having two different names. Okay, we're all good? All right. So we are going to, it says determine whether the lines are parallel, intersect, or coincide. So we have these two lines. For each one of them, we're going to have to look at least the slope and then maybe more past that. So for this first line here, what is the slope? 2, right? What is the y-intercept? 3. Then this one, what is the slope? 2. So we know they don't intersect. They could be parallel, they could coincide, but what's the y-intercept? -1. Okay, so there's the slope and the y-intercept for each one of them. So are these lines parallel? Do they intersect, or do they coincide? They're parallel. So we have to answer that and say these are parallel because they have the same slope and different y-intercepts. Yes, it's a lowercase cursive s. I know. Got to be able to read cursive. Well, let's just figure it out because there's a whole lot of things written in cursive. All right. Good enough? We good? Now, on B, can I just look at this and know what the slope is? I can't just pull a number off, right? I could here, can't here because it's in a different form. So now I'm going to look at, so I can put this in a different form, right? Y equals mx plus b. Now, I said yesterday, I want to make sure you understand what I meant. When I said you're not going to use y equals mx plus b unless you are given the y-intercept, right? Or you're told to. Here we weren't given the y-intercept or told to, but we're also not writing the equation of the line, right? We're given the equation of the line. Putting it in that form is a whole different ballgame. Okay, when I said that, like you're never going to use it, that means writing it. You're not going to write it that way unless you were given that or told to. If it's in one form and you would like it in another because you need the information from it, that's okay. But again, depending on what you need, maybe you don't even need to do it then. But here, having it in y equals mx plus b, I think would be helpful, right? So we will, let's just go ahead and do that. So we get 2y equals 3x plus 7. Okay. So then y equals -3 over 2x plus what? 7 over 2. So then for this one, I know that the slope is what? -3 over 2. My y-intercept is 7 over 2. Okay? We all good? Then I'm going to do this one. So here I just need to divide through. Is my slope 4? No. So y is equal to 4/3 x plus 7/3. All right, so now I look at the slope. It is what? 4/3. Okay, now do we even, I mean, we can see what the y-intercept is, and that's easy. But do we really even care? Because right now, when you look at this, you've got this slope and this slope. Are they the same? No, they're different. And different slopes, they actually could have the same y-intercept. We don't even care about that. Different slopes means that these lines do what? Intersect. So these intersect. There's not a little symbol or anything for that. They intersect because they have different slopes. Good? So this next one, we've got y equals negative 1/3 x plus 5. Do I need to change the form of this line? No. So here I know the slope is negative 1/3. Y-intercept is 5. Then on this one, I do have to do a little bit of work here. So this is going to be y equals, what's negative 2 divided by 6? Negative 1/3 x plus what? 2. Okay, so then here, my slope is negative 1/3. My y-intercept is 2. So same slope. That means they're either parallel or they coincide. What are they? What do they do? They're parallel. So these are parallel because they have the same slope. Same slope. And different y-intercepts. Okay. Everybody okay with that? Good. Here, do I really have to do any work? No. So slope is 3. Y-intercept is negative 5. Then here, I'm going to have to move this over, so I get negative 2y equals negative 6x plus 10. So y equals 3x minus 5. All right, so what is the slope? 3. What is the y-intercept? Negative 5. So what are they? Coinciding. So these are coincide because they have the same slope and same y-intercept. Now I want you to look at every single time we wrote down the slope. Do any of the slopes have an x on them? No. The slope does not have an x on it. The slope is not 3x. It is 3. Do not put a variable on the slope. That is 100% wrong. That tells me you have no clue what you're doing. Okay? So do you have to write the slope and the y-intercept for every single one of them? Yes, you do, because I want to see that you actually know how to write down and identify the slope. Okay? So whether you can see it's coinciding before you write it down or not, you write it down anyway, and then you add that. Okay? That's part of your evidence to back this up. Yes? Yeah, no, that was fine, because like up here, we stopped on the B right there. We knew it was different slopes, so that was fine, because that's all we need to back up what we're saying here. But if we're going to say they have the same slope and different y-intercepts, we have to show that they have that. So that's a good question. All right, anything else? All right, awesome. Next page. Now, do I always have to put it into y equals mx plus b to get my information? The answer to that is no. Using this right here, what form of the line is this? Point slope form. All right, so looking at that, what is the slope? 2. Okay, so that's easy. Is my y-intercept negative 1? Is my y-intercept 10? No, it's not a number I can just pull off that equation. It might happen to be by coincidence, but it's not the same value. So let's think about what the y-intercept is. When it asks you for an intercept, it's actually an ordered pair, right? So which one is 0, x or y? X. Y'all seem a little hesitant with that, right? So when you're looking for the y-intercept, you are looking for what is the value of y when x is 0. Now, we're going to get the y-intercept from this. We are not solving for y to get this in y equals mx plus b. Because did we take some of these that were in this form yesterday and put it in y equals mx plus b, and then you end up with yucky fractions? Yeah, so let's try and avoid that, right? This one actually doesn't end up that bad, but it doesn't matter. I should have put like a bad one on here, but I didn't. So what could I do instead of putting it in y equals mx plus b? Substitute 0. You know x is 0, right? So we are looking for what is y when x is 0. So that means that y minus 10 equals 2 times 0 minus 1, right? All I did was substitute 0 in for x because I know the x value is supposed to be 0. So 0 minus 1 is what? Negative 1 times 2 is negative 2. So y equals what? Okay. Okay, so I can do y minus 10 equals negative 2, right? This is why you shouldn't skip so many steps, right? Because you kind of like, what do I do? You at least write that down, even if you don't write the intermediate step there, so you get y equals 8. So your y-intercept is 8. So we could have done that on a couple other ones. I want you to look back here on this. Because one of the things that you should have been taught is, let's see, let's look at B. What form of the line is this? This is standard form. Y'all looked at that in Algebra 1, right? We didn't talk about it yesterday. You don't necessarily have to use it. But you should know what to do with this. You were taught, I'm sure, how to find the intercepts based on the standard form. Because the x-intercept is what is the x value when y is 0. So if I want the x-intercept, I cover up y, I solve for x. The x-intercept is 7/3. But we don't even care about that right now. We really care about the y-intercept. So the y-intercept is what is the y value when x is 0. So I cover up x, I solve for y, so that's 7/2. That's my y-intercept, right? You should have also learned that the slope is negative b over a. I'm sorry, negative a over b, because this is a, b, and c, right? So negative a over b, negative 3/2, that's your slope. So if you understand the different forms of the lines, it saves you work. It saves you stuff. You have all these tools to put in your toolbox. You got to know what you have so that you can pull them out and use them when you need them. But I think a lot of you just revert back to this over and over and over again. It works, but sometimes things get weird, or it's not even weird. You just mess up because you're writing stuff down. We write it down wrong. So find out, do what you need to do, but you need to make sure that you have the evidence to back it up. Okay? Any questions? All right. Now this says, Audrey is trying to decide between 2 health club plans. After how many months would both plans' total cost be the same? All right, and then we have this little chart of information. So if this lesson is on lines, probably going to have to write an equation of a line. We're looking at whether or not they are parallel, parallel, intersect, or if they coincide. If I'm looking for after how many months they're the same, what should my lines be doing? Intersecting. And what I'm looking for is where they're intersecting, right? So now let's look at our little chart of information here. We've got Plan A and Plan B. We've got an enrollment fee and a monthly fee. If I'm going to write the equation of a line, what does the enrollment fee represent? The y-intercept. Good. What does the monthly fee represent? The slope. These are numbers. It can't be an x or a y. Okay, so it's the y-intercept and the slope. Now, I've got to write an equation of a line. Would y equals mx plus b be a good decision here? Yes, because remember I said, if you are given the y-intercept, I'm given that. I'm not figuring anything else out. Absolutely, y equals mx plus b is easier. There's nothing wrong with that. So for plan A, that's going to be y equals m, which is the slope, 35x, plus b, which is 140. Yes? All right, and then for b, it's going to be y equals 55x plus 60. Everybody okay with all that? All right, so now I've got to figure out when the plans are the same. So who wants to tell me what we do next? What do we do? Set them equal to each other? Y'all agree with that? Yes? Everybody agree with that? Yes? Okay. So y equals 35x plus 140, which equals y equals 55x plus 60. Okay? So then what? Well, you told me to set them equal to each other. That's what I did. I did set the equations equal to each other. Just take out, I just get to randomly decide. Oh, I'm just going to take that out. This is gone. Huh? They cancel each other out? What did you say? I could maybe substitute, right? But is that what you said? No, listen. Shh. I did exactly what you said to do. What you all agreed was, yeah, that's what we do. We have two equations with two variables. What's that called? A system of equations. You currently have two options to solve those. It's either substitution or elimination. There ain't no set nothing equal to anything. Now listen carefully. I realize you may have been told by the person standing at the front of the room that you set them equal to each other. Bad vocabulary. That is 100% wrong. It makes absolutely no sense. And you have to make sure that you understand what you are doing and what you are supposed to do with the correct vocabulary, or when you start explaining things, you're 100% wrong. Because you can say that's what I meant all day long. That does not matter. Had the same conversation with the calculus teachers last week. They're like, kids always say, well, you know what I meant. Yeah, I know exactly what you mean, but that's not what you're telling me, and that makes it wrong. Because this is what y'all told me to do. This makes absolutely no sense. You with me? So my two options are substitution and elimination. This, that doesn't even make any sense. And you don't just go, oh, well, I can just leave y off. No, because some of y'all do things like that. I just leave it off. No, that doesn't make any sense either. You could do elimination. I don't know that would really be the best here. Substitution, like Fee said, would be the best. So what you are doing here mathematically is you have these two equations. This right here is equal to y. So I'm going to take this, and for this y, I'm going to substitute that in for that y. It is a substitution. We're not plugging it in. We're not setting things equal to each other. We are taking 55x plus 60, and we substituted it in for the y. That's equal to 35x plus 140. Everybody with me? Accuracy matters. Terminology matters. You may not think it does, but it totally does. All right, so now we just got to solve this, and I get 20x equals 80. So what does x equal? 4. All right, so are we done? Got to plug it back in? Yes? Okay. So I plug it back in. Why am I plugging it back in? To find out the y, because that's what we do with systems. What does the question say? So what does x represent? The number of months. What does y represent? The total cost. What does it ask you for? After how many months would both plans' total cost be the same? Does it ask you for the total cost? No. So why the heck do you care what it is? You don't care. You don't really even care how many months. You're just doing it because they asked you, right? So can I just box my answer and move on? Really? Because it says solve for x up here? Because I don't see that either. Yeah. The answer is not x equals 4. Did I have to use x and y? No. I absolutely didn't have to. I could use A and B. I could have used a monkey and an elephant. It doesn't matter. I maybe could have used an M for month and a T for total or something that was more relevant. That's fine too. But listen, guys, and I want you to make sure you understand this too. Because I had this conversation with some people after school yesterday, is that being specific about things like this isn't a me thing. This isn't my pet peeve and me being particular. And the only thing that is really something that I'm particular about is I want you to do stuff in pencil. Past that, none of it has anything to do with me. It is about what you are supposed to be required to do. And honestly, there's a lot of things that should have been required of you for years that haven't been. That's not necessarily your fault. That's not my fault either. So it makes me sound like the mean, crazy one because I'm making you be specific. I shouldn't be the first one bringing it up. Okay? So this stuff is important. And if you aren't doing this stuff, you're not going to be successful in high school math, period. You're just not. So x equals 4. That's great. I used x because I wanted to use x. I could have used anything. So my answer is 4 months. Make sure you are answering the question that is being asked. Nobody asked you for x. Nobody asked you for the total either. I mean, I guess you can go find it if you're that curious, but it's a made-up health club, so I don't think you really care. We good? Awesome. All right. Now, this says, given the equation of the line in point P not on the line, find the equation of a line parallel to the given line and a line perpendicular to the given line through the given point. Okay, so I've got an equation of a line. I need to write two more equations. One line that's parallel to this one line that's perpendicular to this one, but they have to go through this point right there, because I have to have a point to know how to write my equation, right? So what is the slope of the line that they gave me? 3. So m equals 3. It does not equal 3x. It equals 3. So when I go to write the equation of the line that is parallel to that line, what slope will I use? 3, because parallel lines have equal slopes, right? When I go to write the equation of the line that is perpendicular to that line, I don't want 3. I want the perpendicular slope, which is what? Negative 1/3, because it is the negative reciprocal. Does that make sense? So now for both of the lines that I have to write, I know which slope to use, and they gave me the point, this point right here. It does not say what form I have to write the equation of the line in. How many of you are still madly in love with y equals mx plus b? Okay, Santos, that's fine. He's not ready to let go. Okay, good. That's all good. Yeah, he's like, me, you ready to kick him to the curb? We're going to break up and move on? Okay, good. He was all like, why am I the only one raising my hand? It's okay. Sometimes it's hard to let go. M times x minus x1, right? So I go and I'm going to write my equation. I'm using this point and this slope for parallel. So this would give me y minus, 3 equals 3 times x minus 2. Then what? We're done. There you go. That's pretty exciting because I'd have to do more if I was going to do the other, right? Okay, so then I have to write an equation of the line perpendicular to it. This is the slope I'm going to use. I made that decision before I started. Still using the same point. So now I get y minus 3 equals, I use this slope, negative 1/3 times x minus 2. That's it. You're done. Yeah. See, now you know you were ready to break up, right? Okay. Any questions? Yeah, still got some good quality. We can still be friends. That's okay. But all right, and we're done with Bob. Okay, next page. All right, so I'm going to give you a couple minutes. I want you to work on this one on your own. Okay, so I want to know, actually, just first tell me, what did we get for the slope? 2/5, right? Okay, it is 2/5. All right, and then this is 5th period, right? I want to know if when I write my equation of my line that is parallel to it, okay, I need to fix this. This is like way bad, wrong. Mirabella. All right, what would be my slope when I write my parallel line? 2/5, right? Okay, good, thank you. What would be the slope when I write my perpendicular line? Javier. I'm going to call you Javier now. Negative 5/2. Oh, I did. Thank you. It's the perpendicular slope. Let me read it. You're on it today. Yes. It's negative a/b, right? So. All right. So, yes, you need to write that it's the slope and the perpendicular slope, so you're not getting them mixed up. Okay. So we've identified our slope and which slopes we need to use. This is the point that we're going to have. So then what would the equation of my parallel line be? Jose. Huh? Oh, he's not in this. Oh, sorry. I thought I was in the next period. Oh, that's right. He's in the next period now. See. I really need to take some time to fix this. Okay, Cameron. So what would my equation of my line be? Plus 2. Okay, good. So you get the minus and negative. There you go. All right, y'all agree with that? Yes? Okay, awesome. Thank you, Cameron. All right, and then my perpendicular line, what would that be? Fernando. Okay. Times x plus 2. Good job. Thank you. All right, any questions about that? All right. Now, do you want to go on? I mean, we can put these in y equals mx plus b if you want. No, right? So yesterday after school, this girl told me, she was like, you know, today when you said, I'm going to make y'all all believers by the end of the class, I was like, no way is she going to change my mind. I said, did I change your mind? She was like, yeah, you told me. change my mind. Okay, guys, just so you, in case you didn't realize it, I know what I'm doing. Right? I'm not going to lead you astray. I'm not going to make it harder on you to make it harder on you. I've been doing this longer than you've been alive. So I know what you're going to say when I ask you a question, when I know you're all going to give me the wrong answer, like set it equal to each other. I mean, I've gotten that every single period for years. So I know what's coming. All right. Any questions? All right. Here we go. Now this says, write the equation of the perpendicular bisector of the segment with the given endpoints. And we got these 2 points. So we're going to start by drawing our little our ballpark graph. So -3, 9, and, oh, shoot. I need to see, and then the other one's -5. So I'm going to move my 3 over some because that's not good. All right, so -3, 9, -1, 5, somewhere right about there. So I've got this line segment. All right, so am I trying to write the equation of the line that pink segment lives in? No. It says that I want the perpendicular bisector of that segment. Okay, now when I write an equation of a line, I need at least a point and a slope. That I don't know what the y-intercept is, so since they didn't give it to me, I'm not using that. So I'm going to use a point and a slope. So I'm going to need a point. How would I figure out which point I would use when that's not even the line? Okay, the midpoint. Because if it's the perpendicular bisector, this is a line, right? It's going to intersect at the midpoint, right? So here's the midpoint, and because those would be perpendicular, right? And then it's going to be, when the line crosses through the midpoint, does it matter what angle it goes through at? Yes, because it is the perpendicular bisector, so it's got to come through at a 90-degree angle, right? We good? So in order to write the equation of the line, I need to find the slope, and I need to find a point. Specifically, it's going to be the midpoint. Right? Everybody with me so far? Okay. So this is how, when you read this question, a question like this, instead of sitting there and going, I don't know what I'm supposed to find, I don't get it, you have to step yourself through the process. Start thinking about how I'm asking you those questions. I didn't tell you anything. I asked you every single bit of that, and you were able to answer all of it. So you got to learn how to question yourself when you think you're stuck, because usually you're not really stuck. Okay, so am I capable, based on what they gave me, to directly find the slope of the line I want to write the equation of? When I put points in the slope formula, I'm not getting the green line, right? That's not what I'm getting. I can find the pink one, though, right? And then will that help me get what I need? Yes. Okay. So I'm going to start off by finding the slope. So my slope is delta y over delta x. And so that is 5 minus 9 over -1 minus a -3. So that's going to give me -4 over what? 2. So that gives me a -2. That is the slope. Right? Now, is that the slope I'm going to use? No, I found that. What I'm going to use is the perpendicular slope, which is what? Positive 1/2, because it's the negative reciprocal. So take the reciprocal, change the sign. This is the slope that I'm using. Everybody with me? And that's why you need to write perpendicular, because you need to distinguish between the two, or you're going to end up confusing yourself, and it's also not something somebody can follow. Okay. All right, so then midpoint. My midpoint equation is x1 plus x2 over 2. y1 plus y2, oh my goodness, write and talk at the same time, y2 over 2. So midpoint formula is easy. This is going to give me -3 plus a -1 over 2, 9 plus 5 over 2. So this gives me, that's -4 over 2, which is -2. And then a positive 14 over 2, which is 7. So this is the midpoint of the pink segment, which is a point on the green line. Now, a common mistake I see a lot is that people will go through and find the slope and maybe even use the right slope, but then use one of those 2 points. Well, that's just going to give me a perpendicular line through one of the endpoints, which is not what it's asking for. Okay? So make sure after you find what you need to find, you find this, you use the right thing, and that you actually find the midpoint. Now that we have that, we can go and write the equation of our line in point-slope form. So I'm using, I'm not using those anymore. I'm using this. So this is going to give me y minus 7 equals 1/2 times x minus a negative 2. Remember, cleaning it up does not mean go forth and do all of the math you could possibly do. It means you get y minus 7 equals 1/2 times x plus 2. Now, again, it did not say that you have to use point-slope form. Is that the best decision here? Yes. I mean, it's a matter of opinion, but it's yes. Now, if you did go forward and put it in y equals mx plus b, as long as it was correct, I would take the answer because it doesn't say to do it another way. But don't ever take and try and pick the y-intercept off the graph because that's guessing, and we're not guessing around here. Okay, we good? Questions? Awesome. All right, go ahead and glue that in.